Hello, so let's begin. Ajke physics, right?
Yeah.
Okay, let's actually start.
Before we start, I wanted to tell you, I think আমাদেরকে paper 4 এর জন্য exemption দিচ্ছে, but paper 4, paper 6. So since I did one paper for physics with you, I found paper 4 easier. So I'll do paper 4 physics, but I'll take exemption for paper 6, I think, biology.
Okay, so by the way, what was paper 6 again? Physics or the paper?
Biology হচ্ছে কি paper 6 এ আর physics এ paper 4 টা।
এগুলো কি exemption হচ্ছে?
আপু বেসিক্যালি সায়েন্সের সাবজেক্টে সবই এক্সামশন দিয়ে দিচ্ছে, বাট আমি সব নিব না, আমি জাস্ট বায়োলজি পেপার 6 বিকজ আমি ওটা টাচও করি না, এখন নতুন ইনফরমেশন নাও, আই ডোন্ট থিংক ইটস দ্য বেস্ট ডিসিশন ফর মি।
ওকে, সো ফিজিক্স এর কোন পেপার গুলো নিতেছো?
ফিজিক্স এর পেপার 1, পেপার 2 আর পেপার 4 অল্টারনেটিভ টু
আচ্ছা,
প্র্যাকটিক্যাল সেটা, আর বায়োলজি জাস্ট পেপার 1 আর পেপার 2।
Oh, okay, great. Okay, you told me that physics এ তোমার basically কিছুই প্রপারলি পড়া হয় নাই, সো অবভিয়াসলি প্রথম থেকে আমি ডিটেইলি স্টার্ট করব। Okay, so I actually went through your syllabus and yeah, so the first, I'm going to start from the very beginning. So I made a few notes, just a moment. Yeah. Great. Okay, let's start with physical quantities, units, and scalars and vectors, all these kind of stuff. Yeah. Okay. You know what physical quantities are?
Yeah, they're like, for example, you said the vector and scalar. I could describe that.
Okay, so physics, everything you come across is a physical quantity, starting from mass, length, speed, velocity, density, you name it. Every single quantity that you deal with in physics is a physical quantity. Okay, so it is actually two types. I'm sure you have heard this before. One is basic quantities. Okay, another one is derived quantities. So basic quantities, there are actually 5 of them, and basic quantities শুধু এই 5টাই হয়. I'm going to tell them in a moment. And derived quantities, they are actually, like the name suggests, they're derived from the basic quantities. Okay, so they're like, they're sort of yeah, they're dependent on the basic quantities, or ওইখান থেকেই আসতেছে. So what are the basic quantities? So obviously we have length is a basic quantity, mass, time, thermodynamic temperature, and amount of substance. That's it. These 5 are the basic quantities. Okay, so what is the unit of SI unit, System International Unit of length? What is it?
Meters.
Exactly, meters. For mass, it is
kg.
Hello?
It's kg, right? Kilograms.
Exactly, yeah, it's kilograms. For time, it is seconds. You can just simply write S. For thermodynamic temperature, it is Kelvin, and for amount of substance, it's moles. Okay, so these are basically the basic quantities that you have to remember. And derived quantities, আমি কয়েকটা example দিব. Derived quantities are basically endless, like everything that is, derived from these are derived quantities. For example, let's give some examples. Density is a derived quantity. What's the unit of density? Volume per mass per volume. So that is
Yes.
like kilogram per meter cube, for example. And then area is another derived quantity, that is meter squared. Volume as well. And then what else? Yeah, even the electricity chapter অনেক derived quantities আছে. Even energy, that is joule, is a derived quantity. So okay, so everything is a derived quantity other than these five. Okay, and then what else? You need to be able to you need to be familiar with the conversions. Sorry, blue color for one. Like, 1 kilometer is equal to 1000 meters, and then 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. You need to be able to know these conversions, obviously. Egula literally shop chapter lagbe. Yeah, so I'm going to give you the list of prefixes so that you can always use them. Like prefix bolte kilo, centi, deci, tarpor giga, mega, egulo shop prefix. Okay, and you can
Yes.
use these prefixes in front of any unit. So let's start with, I don't know if you guys have tera, but I'm just going to include them anyways. Mega. Okay, tell me to stop if I'm going really fast or if you cannot understand something. Okay. Deci, centi, milli, micro, nano, and finally pico. Okay, I'm gonna give the symbols. Obviously, this is capital T, this is capital G, this is capital M, this is small k, this is small d, this is small c, M, finally P. Okay. Now, what power do they have? So, tera mane hoche 10 to the power 12. And giga means 10 to the power 9. Mega 6. Kilo 3. And then from deci, it's actually minus. So, -1, -2, -3, -6, -9, and -12. Okay. I hope you know what minus is. It basically mane hoche 0.1.
Yes.
Etar mane hoche 0.01. Yeah. Okay.
Yeah.
All right. So once you're done noting them down, I can move on.
Upon done.
Okay. So next hoche, yeah, scalar vectors. So I'm trying to figure out, wait, I kind of feel like I missed out on one basic unit, basic quantity. পাঁচটা হয় নাকি ছয়টা হয়, I got confused now. Wait, just a moment. Yeah, I missed out current. That's why I was like, must be missing out something. So wait, another one is actually, another base quantity is actually electric current. the unit is ampere. So yeah, this is another basic quantity, because this is not derived from anything. This is actually a fundamental. Okay.
So other than these basic 6 unit, everything else they're derived.
Yeah, everything else are derived. Okay. Uh, then I can move on. Next, which is scalars and vectors. So let's talk about that. Okay. So what is a scalar? You already know that, hopefully. Um, what is a scalar?
Scalar units, they're units that have only direction but no magnitude.
You actually said the opposite. So it
Oh,
has
sorry.
only,
It has magnitude and no direction. Sorry.
exactly, yeah. So this has only magnitude, that is the numerical value, but no direction. Now, um, scalars are basically, yeah, any sort of quantity that can only be described using a numerical value. You don't have to specify the direction. Okay, I'm going to give you examples just in a moment. But first, let's understand what's a vector. So this one has both magnitude and direction. So without the direction, it's actually useless. So a vector will always needs a magnitude and a direction. Okay. So I'm going to give you a couple of physical quantities. You'll have to actually tell me, what is a scalar and what is a vector. It's a small, let's say, quiz. Okay.
Yeah.
Yeah. Giving you a few minutes to do this. I'll be back and I'll check it. Okay.
Okay. Okay, I'm done.
Hello.
Yeah, boom, done.
Okay, great. What did you write for number one?
One is scalar.
Exactly, one is scalar.
Uh, number two is vector.
Mm-hmm.
So is number three.
Number three?
It's also vector, right? Because it says north. It has a direction.
Exactly. Number four?
Number four is scalar.
Mm-hmm.
So is number five and six.
Exactly. So all of these are scalar except for the one that has north and east mentioned in it.
Yeah.
So yeah. So what does it actually tell us? So mainly, scalars are distance, length, speed, time, mass, all of these are scalar. So I have to actually list them down so that you can understand. So scalar ধরো, let's write in different color. So scalar হচ্ছে distance and then length, speed, time, mass, all of these are scalar quantities. For example, distance আমি এখানে একটা example দিছি, this is scalar. তারপর length, similarly it could be like 5 meters as well. Length and distance both গেলে interchangeable. Speed, yeah, when you don't mention, like for example a direction, that's a speed. So even 30 meter per second is a speed. So without the direction it's actually scalar, but if you add the direction it actually becomes a vector. Time is definitely a scalar quantity. Mass is also a scalar quantity. So what are vectors? Vectors are, for example, displacement. People get confused between distance and displacement, but the difference is that displacement needs a direction. Okay. Yeah. And then Arkijani have velocity, acceleration, force. That's it. These are vector quantities. Okay.
Yeah.
All right. Once you're done, let me know.
Boom.
Okay, great. Now for vector quantities, you actually need to be able to find the resultant vector, or maybe the resultant force. Just a moment ago, I mentioned that force is a vector quantity. So let's work with force, okay? So for example, when you draw a force or a vector, any vector actually, you put a direction like that, and then you mention an angle, right? So for example, this is 30 degrees, and this is a force, which is, let's say, 5 Newton. Okay, so this is telling us that the force magnitude is 5 Newton and the direction is 30 degrees, right? 30 degrees, and you could even say that it is anti-clockwise. Okay.
Yeah.
Yeah, so that's how we actually represent vectors. এখন তোমাদের syllabus-এ apparently you need to know how to find the resultant vector or resultant force. So find the resultant force, or you could say vector. Okay, so ধরো দুইটা ফোর্স তোমার কাছে দেওয়া আছে। ধরো this is a question. You have like one force right here and another working right here. So let's say this is F1, which is 4 Newton, and dharo this is F2, which is 20 Newton. Okay, so you're told to find the resultant force. So how would you find it?
It's there's going to be a line drawn with the two arrows, right? Or in between.
Exactly, in between. So how do you actually do it? There are two methods to do it. I'm going to teach you both. Specifically তোমার syllabus graphical methodটাতে বেশি stress করছে, but I'm also going to teach you the trigonometric method. So let's talk about that one first. Method 1 is trigonometric method. Okay, so what you do in this case, simply wait, you have to make it a rectangle first. Okay, and now middle থেকে you already know the resultant বলতে গেলে এখানে হবে. So this is, let's say, R. Okay, and this is our theta. So how do you find the magnitude? You can use Pythagoras theorem. Right, so R is equal to, you can say F1 squared plus F2 squared. That is the Pythagoras theorem. And then that is 4 squared plus 20 squared. What does it give us?
Just a second, I'll go get my calculator.
I think it's 20.4 Newton. Okay. Yeah, so now you know the magnitude of R, and now it's not enough because you need to know the direction as well. So you need to know the theta. So theta কিভাবে বের করবা? Simply tan theta দিয়ে বের করতে পারবা. So tan theta is equal to opposite. This is the opposite by adjacent, and this one is actually, you can say that this is 4 Newton. Why? Because এটা এই সাইডেও ধরা যায়. Okay,
Yeah.
so 4 by 20, this is what, 1 by 5. Yeah, I need to use a calculator now. Okay, that's 11.3 degrees. Okay, now yeah, you're done. Another method of solving this is graphical method, and I'm also going to teach you that. First, please note it down.
Up here, do you have to write anything like this is going towards, like with one teacher I once did it, like it's going towards north or south or a certain direction? Do I have to write that too?
No, I think if you want to write an answer like formally, you can simply say that force R is equal to 20.4 Newton. You know, 11.3 degrees. Anti-clockwise. Or you can simply show this sign. I think that's enough. আসতেছে আমার ল্যাপটপটা। Okay. Hello, did you note them down?
Yeah, আপু, I'm done noting it down.
Okay, great. Now the same question, just with a different method. This is known as graphical method. So let's draw the same two forces. So this is 4 Newton, this is this is 20 Newton. And now again, we'll draw this rectangle. And then obviously এটা আবার মাঝখান দিয়ে যাবে, so draw your R. But now instead of using Pythagoras, we're actually going to be using our ruler, so scale. তুমি just physically obviously draw করতে পারবা and measure করতে পারবা. So first of all, you actually have to choose a scale. Okay, so that is the first step. Choose a ratio. Like, I think in this case the best would be to use 1 centimeter as 2 newtons. So a line ta koto hobe? 10 centimeters, and a line ta hobe 2 centimeter in your with your ruler. So এটা যদি আঁকো, and then তুমি যদি এই লাইনটা ড্র করে মেজার করো যে এটার লেংথ কতটুকু আসে এখান থেকে এখানে, so you'll actually be able to see that it is approximately like, I don't know, 10.4 or something. And then if you convert this 10.4 into Newton back again, so you'll be able to see that is approximately 20.4 as well. Okay, so you can see যে Pythagoras or graphical এর মধ্যে বেশি difference নাই answer এর মধ্যে. So if you choose either of them, like the accuracy is like quite high. You don't have to worry about it. Okay. But if they specifically tell you use the graphical method, you have to do this one. So you have to choose a scale first and then draw everything according to the scale. Okay.
Yeah. Apu, in here, do we not need to get the theta?
Oh yeah, you need to find the theta. So for the theta, just use a protractor. Okay.
Yeah.
So yeah, in the examination তোমার এই দুইটা জিনিস নিয়ে যেতে হবে, একটা scale and একটা protractor, and obviously pencils.
Yeah.
Okay. All right then. That is it for vectors. obviously, as you'll do like worksheets and question papers with me, you'll be able to see এত easy কখনোই দিবে না যে সবকিছু horizontal and vertical. There will be like angles like this, so you have to draw somewhere here. Okay. Right. Yeah, there will be multiple angles, so you don't be afraid of this because should be solved kora possible এই দুইটা method দিয়ে. Okay.
Yeah.
All right, so then we can move on to how to measure different lengths, I think. Yeah. So I'm going to give you a handy table actually. I'm not sure tomorrow boy Sakina, but this can always help. So yeah, by the way, we're now studying no, actually measuring lengths. Let's call it that. Okay, so now let's draw a table. Okay. Yeah, if you have a length, for example, that is greater than like 100 centimeters or something, so greater than 100 centimeters, and what equipment will you use? I'm going to write it down. And what if your length is between 5 centimeter and 100 centimeter? And then what if your length is between 1 centimeter and 10 centimeters? And what if your length is less than 2 centimeters? Now, even if the length is like, 5 to 10, you can still use this one, but this one will give you more precision. Okay. Uh-oh. Okay. So for very large, for very long distance or length, you can simply use a measuring tape. For 5 centimeter to 100 centimeters, you can simply use a meter rule or a scale. For 1 centimeter to 10 centimeters, with precision, you can actually use a vernier caliper. And for a length less than 2 centimeter, you can use a micrometer screw gauge. Okay. Now, you need to be, you actually need to know their, how do I say it? Yeah, their precision, like their least possible value. Okay. So for example, this one for measuring tape, the precision is not quite high. It's only 0.1 centimeter. Okay. Why did I write this? Because তুমি যদি একটা measuring tape দিয়ে কোনো কিছু মাপো, তুমি দেখবা you can only say যে okay something is 50.5 centimeter বা 20.4 centimeter. You'll always, sorry?
Nothing.
Okay, you'll always be able to say okay 50.5 but 20.4, but you'll never be able to say okay this is 20.42 centimeter, because এত information একটা measuring tape clearly দেয় না. Okay.
Yeah.
So that's what I mean by 0.1 centimeter plus minus. That is the precision. And then for meter rule, I think you already know that is 0.1 centimeter as well. তুমি যদি তোমার একটা scale check করো, দেখবা যে the least value that you can get is 0.1 centimeter. So for example, তুমি একটা কিছু মাপতেছো, that will only be like, you'll be able to record it as like 5.4 centimeter or maybe 6.7 centimeter, but you can never say, okay, this is 6.73. Okay,
Yeah. Yeah.
that is what I mean by precision. Okay, vernier caliper বেলায়, obviously it gives you more precision than meter rule, so that is going to be plus minus 0.01 centimeters. So if you actually measure something using a vernier caliper, you'll be able to find it is 5.42 centimeter. You can actually very easily read this value. Okay. Okay, what about micrometer screw gauge? It gives you even more precise results. So plus minus 0.001 centimeter. But obviously you cannot use micrometer screw gauge for something very large. So যেটা measuring tape দিয়ে measure করা যাবে সেটা তো obviously micrometer দিয়ে করা যাবে না, because এটা একটা limitation আছে. It can only measure very small lengths. Okay. Yeah, so for applications, micrometer, for measuring tape, we typically use them, for example, to measure the waist of a person, etc. I'm just going to write down one application for each. Okay, so meter rule যেরকম height of an object, for example. Vernier caliper, give me an example.
We measure the diameter of an object.
Exactly. So like diameter of a pipe, for example. Okay. And then micrometer screw gauge, it's quite common to use it to determine a wire diameter by length. Okay.
Yeah.
Yeah, that's it. So all you need to know is these four. There are four equipments to measure different lengths, and you have to choose a particular one for a particular situation. Okay, so I think if you know this is more than enough. Okay.